There are moments in the car world when someone pulls back the curtain and everything we thought we knew gets turned upside down. This is one of those moments, because when the legendary engineer Sandy Munro and his team tore apart the Tesla Cybertruck's motor and the Chevy Equinox EV motor, what they discovered wasn't just a difference in engineering. It was a battle of philosophy. Two giants, Tesla and General Motors, both chasing the same goal: efficiency, power, and longevity. But the way they achieve it couldn't be more different. And the truth Munro found inside will leave you questioning everything you thought you knew about electric cars. The man who knows what's inside. Sandy Munro is not your average engineer. He's the man car companies fear and respect. Because when he takes your car apart, he finds the truth. No marketing, no glossy press releases, just raw, mechanical honesty. For years, his company, Munro & Associates, has been the ultimate X-ray machine for the automotive world, tearing down Teslas, Fords, Chevys, and every EV you can think of. And when Munro speaks, the industry listens. So when his team got their hands on a Tesla Cybertruck motor and a Chevy Equinox EV motor, what they found wasn't just different, it was revolutionary. The secret world inside an electric motor. You see, it's nearly impossible for the average person, or even a car reviewer, to truly know what's going on inside an EV motor. We can talk about horsepower, torque, and 0 to 60 times all day long, but the real story lies within, in how it's cooled, how it's built, and how it handles stress under extreme conditions. That's where efficiency lives or dies. And according to Sandy Munro, Tesla and GM have two completely opposite approaches to solving the same problem: keeping those electric motors cool. Because when you're pushing out thousands of RPMs, battling heat is the difference between a champion and a meltdown. When power meets heat, let's start with something wild. A few months ago, a Xiaomi SU7 Ultra, a 1,500 horsepower electric monster, raced against the Tesla Model S Plaid. Logic says 1,500 horsepower should destroy the 1,000 horsepower Plaid, right? But no, Tesla won. And the reason? Cooling. The Xiaomi overheated halfway through the run, while Tesla's powertrain stayed calm, precise, and relentless. That one drag race proved just how critical motor cooling really is, and why Tesla keeps dominating the EV performance game. The Chevy approach: smart, simple, and old-school genius. When Munro's team cracked open the Chevy Equinox EV motor, they found something fascinating: a cooling method that's elegant in its simplicity. Instead of using complex pumps and extra plumbing, General Motors uses the motor itself as a built-in oil-flinging machine. As the motor spins, it throws oil upward into small cast channels. Then, like rainfall, that oil trickles back down over the motor's windings, magnets, and casing, cooling everything naturally. No extra energy drain, no fancy machinery, just physics doing its thing. It's brilliant. It's cheap to produce, and it's dependable, mostly. This method actually borrows from something Toyota mastered over a decade ago with the Prius C, using the motor's motion itself as the cooling mechanism. GM saw that idea, improved it, and tailored it for their electric SUV lineup. But there's a catch, and it's a big one. When the Equinox is stopped, like sitting in traffic on a hill or idling in summer heat, that cooling oil doesn't move much. And that means heat builds up where you least want it, inside your motor. For a car that's meant for everyday driving, it's fine. But push it hard, or drive it in extreme conditions, and that simple genius can become a limitation. Tesla's way: precise, powerful, and expensive. Now let's look at Tesla's motor, the one ripped from the Cybertruck. Where GM uses simplicity, Tesla uses precision. Instead of relying on motion, Tesla uses a high-pressure oil pump that forces oil through tiny channels, targeting the exact components that need cooling: the electrical windings, the magnets, and other high-heat spots. It's surgical, controlled, and incredibly effective. This allows Tesla to run cheaper magnets without relying on rare earth metals, yet still maintain high performance and long-term durability. But the real genius? By keeping only the important parts cool and letting the casing stay warm, Tesla avoids something most engineers dread: eddy currents. The invisible enemy. Eddy currents are small whirlpools of electricity that form when magnetic fields flip rapidly inside the motor. They sound harmless, but they're not. They waste energy, create extra heat, and reduce efficiency. But Tesla's approach, keeping the outer casing hot while cooling the core, raises the resistance of the metal, making it harder for these unwanted currents to form. It's one of those invisible engineering moves that make Tesla vehicles absurdly efficient without anyone realizing why. And that's exactly what Munro's team noticed. The Tesla Cybertruck motor doesn't just stay cool, it stays smartly cool. The cooling system knows where to spend energy and where to save it. The trade-off. Now let's be clear, Tesla's way isn't cheap. All that extra machining, the precise channels, the pump, the plumbing, it costs money and adds complexity. GM's way cheaper, fewer parts, less to go wrong. But here's the thing, Tesla's method means more power, more consistency, and more efficiency, especially under heavy load or extreme driving. GM's method works beautifully for affordable EVs designed for daily use. Tesla's method, it's built for performance. So what you're really seeing here isn't one being better. It's two different philosophies for two different missions. The long-term game. But if you look long-term, Tesla's design holds the upper hand. Because over time, stop-and-go traffic, scorching summers, fast bursts of acceleration, the Equinox-style cooling starts to show its limits. Meanwhile, Tesla's precision oil system keeps working, lap after lap, year after year. That's why the Tesla Cybertruck motor, despite being more expensive, is considered technologically groundbreaking. It's not just powerful, it's efficient, reliable, and future-proof. Munro and Associates put it perfectly. Tesla's approach may be complex, but it allows them to reduce costs inside the motor and extract every ounce of performance. In other words, Tesla isn't just building motors, they're engineering dominance. Sandy Munro's verdict. After tearing both motors apart, Sandy Munro's verdict was clear. Both designs are clever, both work. But Tesla's approach shows a deeper level of understanding, a kind of engineering artistry that balances cost, cooling, and efficiency in ways no other automaker has matched yet. GM's solution is practical. Tesla's solution is perfectionist. And when you compare the two side by side, one powered by simplicity, the other by precision, you start to see the real story behind the EV revolution. It's not just about batteries and range. It's about the battle happening inside the motor, the battle for how energy moves, cools, and flows. The takeaway. At the end of the day, this teardown revealed more than just parts and metal. It revealed mindset. Tesla builds for performance and innovation. GM builds for practicality and affordability. Both are valid, both are important, but it's Tesla's willingness to spend more, to complicate things, to rethink every drop of oil that touches their motors. That's what sets them apart. So next time someone tells you Tesla's dominance is just marketing hype, remember this: it's not hype, it's heat management. Sandy Munro's Teardown didn't just expose two motors, it exposed the soul of two companies. One chasing efficiency through elegance, the other through innovation and precision. And in that tiny space between oil, heat, and magnets lies the future of every electric car we'll ever drive. So tell me in the comments, whose philosophy do you think wins the race? The simplicity of GM or the precision of Tesla? And if you love deep dive stories like this one, hit that like button, subscribe to EV Tech, and tap the bell icon, because we're just getting started uncovering the secrets behind the machines that move our world.